Alright, here I'm going to do two examples of solving quadratics using square roots. Before we get started, one thing to note is that we solve quadratics using square roots when the equation is not in standard form. Just to kind of recap, standard form is when it's y equals ax squared plus bx plus c. And once again, we use square roots when we're not in this form. So for instance, if I look at this form over here, example 1, you'll notice that I have an x squared, but I don't have an x, so I'm in non-standard form. So I can use solving quadratics by square roots in this problem. So the first thing we want to do anytime we're given a problem in non-standard form and we're going to solve it using square roots is we want to get the stuff being squared by itself. So right now I have this x squared here. I want to get that by itself. Well, I know I can get it by itself first by getting rid of the negative 31, and I can get rid of the negative 31 by adding 31 to both sides. This is going to give me 4x squared on the left hand side equals 80 on the right hand side. Now I can divide by 4 to get rid of the 4. I'll be left with x squared equals 20. Now I have the x squared by itself. This is the step now where I want to take the square root of both sides. So I can take the square root of the left hand side, the square root of the right hand side. I'll be left with x equals the square root of 20. And then because I'm the one who added the square roots to the problem, the square root wasn't originally in the problem, I really need to put a plus or minus sign on that square root of 20. The last thing I need to do here is any simplifications that I can, and I can see that the square root of 20 is the same thing as the square root of 4 times the square root of 5. And then the square root of 4 is just 2, so this is really x equals plus or minus 2 times the square root of 5. Looking at my second example here, once again, I notice that it's not in standard form. And this time I have x plus 3 inside the parentheses being squared. But I'm still going to kind of follow the same steps I did last time. The first step is always to get the stuff that is being squared. So whatever stuff is being squared, I want to get that alone. Okay, by itself. If there's anything attached to it, whether it's added to it or whether it's multiplied to it, I want to get the stuff being squared alone. And then my second step will be to take the square root of both sides. Okay, so square root both sides after that. So for instance, if we look at this example here, I have 2/5 times x plus 3 squared equals 5. I first want to get the x plus 3 squared by itself, so I need to get rid of the 2/5. Now, I can get rid of the 2/5 by multiplying by its reciprocal, 5/2, and I want to do that to both sides. Well, this one will just cancel. I'll be left with x plus 3 squared equals 25 over 2. At this point, I'll notice that I have the stuff being squared alone. So here's where I start my second step of square rooting both sides of the equation. So I take the square root of both sides. Notice that anything that's being squared and a square root will cancel with each other. I'll be left with x plus 3, and that'll be equal to the square root of 25 over 2. Now, once again, I'm the one who added the square root to the problem. It wasn't originally in the problem, so I need to remember to put the plus or minus sign on that. And then to solve for x, I need to get rid of the plus 3, so I can subtract 3 from both sides. So at this point, I'm going to get x equals plus or minus the square root of 25 over 2, and then that's going to be minus 3 on the end. Now, the last thing I need to do is simplify the radical. So anytime I have a radical of a fraction, I can really rewrite that as the radical of the top, so the square root of 25 over the square root of 2, and then the minus 3 will just stay off to the side. Well, if I think about the square root of 25 for a second, 25 is a perfect square. It's a perfect square of 5. So I can rewrite this as x equals plus or minus 5 over the square root of 2 minus 3. And then the last thing I need to remember is in math, we never leave a radical on the bottom of a fraction. So I need to do what's called rationalizing the denominator, where we multiply by the same radical over itself, and this will help cancel it from the bottom and move it to the top. So for instance, I'm going to get x equals plus or minus, if I take 5 times radical 2, I'll just get 5 radical 2, and then that'll be over, and if I take radical 2 times radical 2, well, that's radical 2 squared, and radical 2 squared is really just 2, and then I still have to subtract 3. This will be my answer for the equation up here.